Yeah, my husband's a handy dandy engineer. He built that little thing for me. He's a big guy. How many of you use the weight room? Anybody here use the weight room? You know the boxes, the step up boxes? My husband built those too. He's a good guy. Oh, that's a good question. Because I will forget. Oh, we still have a lot of time before lunch. Yeah. Just sit back and relax. We got plenty of time. All right, so here we go. Number one, we're on our P1 notes. Number one, yes, keep reminding me. Lunch is supposed to be at 12:15. So make sure I don't lose sight of that. All right, 15/8, it's a nice little rational number. Our job is to turn it into a fraction. Who knows how to do this? Remember, this is stuff you already know how to do. Be brave, speak up, come on. How do we do this?
Divide.
Divide. What gets divided by what? What goes inside, what goes outside?
8 goes outside.
Yep. Beautiful. Beautiful. Bottom number goes on the outside, the top number goes on the inside. Perfect. And we're going to divide. Now, you've done this enough, you know we're probably, put that calculator away. We're going to add some zeros there. Right? And here we go. 8 goes into 15 once. Subtract. All right, bring down the 0. How about 8 into 70? 6. 8? Yeah, I think it's 8. Because isn't 8 times 8 64? Yeah. Now bring down another 0. Remember, we just keep bringing down zeros. All right, how about into 60?
7.
7. Oh, now I think we're finally done because 8 goes into 45. So 1.875. That decimal right there is called a terminating decimal. Have you heard that word before? Terminating decimal. What does terminate mean? End. Stop. Finish. Right? Eliminate. So, yeah, the division is eliminated. We are done. We're done. That's a terminating decimal. Now, let's compare that to the next one. Now, don't get all hung up about the negative. That just means in the end, our answer will be negative. So I'm not even going to worry about it. Again, for the division, what goes in and out?
11 goes in.
11 is in, 6 is out. I'm going to need zeros again. Here we go. Goes in one time. Okay, 6 into 50.
8.
8. 6 into 20. 3. Uh-oh, I heard somebody say it. Uh-oh.
Yeah.
What's happening?
It's a repeating decimal.
It's gonna keep going. Do you see how that works?
Yeah.
So instead of, we're not gonna keep going, we're just gonna put a little bar over that 3. Now, don't put it over the 8 and the 3. It only goes over the 3, right? That's called a repeating decimal. When you put all of these together with all of those, all the terminating and all of the repeating, you have what we call a rational number. So when someone asks you about a rational number, you know that it's a decimal that either stops or repeats. All right, number 2, describe and graph. All right, well, first of all, let's suppose that, I need to take attendance. Let's suppose somebody's absent today and you're trying to explain this over the phone, but they can't see it. How would you say this in words to them? What does this say?
X is greater than 3.
X is greater than 3. So what are we talking about then on the number line? We're talking, here's 3. We're talking about all of the numbers to the right of 3. So that's what the graph looks like. Now, sometimes when I graph these, I close that dot in. Why didn't I close it in this time?
There's no bar
There's
in.
no, this is called an or equal to, and there's no or equal to. So that would be the only difference If that had a line under it, then I would color in that dot. Okay, what about this one then? What about this guy? What does he look like? What are we talking about there?
Oh, that's an and statement.
Yeah, it's a compound inequality, and it says two different things, and they are and. Okay? I would rather just leave it together as one piece, but certainly you can split it into two. What does it look like graphically?
You'd have two dots.
You have
and-
two dots. Kids, a number is going to be a dot. So I'm gonna have some kind of a dot at -4 and some kind of dot at 2. Open or closed?
Open,
close at -4.
-4 is gonna be
Okay.
open and 2 is gonna be
Closed.
closed. Now, in my last example, I shaded everything to the right. Where am I shading in this guy? It would be in the middle. And before somebody says, oh, that's confusing, stop. Where's the X? In the middle. You're shading where the X is, okay? The X is in the middle. So you're gonna shade in between those. Perfect. All right. Now C is a little bit different. Last year, did you guys talk about interval notation? Open and closed intervals. In your next math classes, starting with this one and then going on, we really don't use this notation that much. We use a shorter notation called interval notation. This notation means this. It means numbers in between -1 and 3. So this is not like an ordered pair, like you would plot like that. That's not what this is. This is an interval. So this would be graphed just like this one. You have a dot at -1 and a dot at 3, and then you want all the numbers in between them. Now, if I look at problem D, it's almost exactly the same thing. Except for what? What's different about D?
There's a bracket.
It has a bracket. It's still gonna involve two dots. One of them is gonna be closed. The parentheses is open interval. That's your open interval notation. The bracket is closed, so you'll close in the -2 dot, leave the 6 dot open, and shade in between. Bracket, closed, parentheses open. I hope you're sitting there thinking, oh, this class is gonna be easy. It's so easy. And then I throw this one at you. What in the world is going on with that guy?
It means it's, for going on in an endless line, depending on which direction it's going.
Exactly. So that, oh, I think I erased it, but we had one before that was like this, and we colored in like that. So he's saying this is that's what's gonna happen with this one. But what we have to be careful about is, which way's that arrow gonna be going? Exactly. Because if I look at my number line, here's 4, and actually that would be closed in, right? Now this end of the number line is -infinity, and this end is positive infinity. So what's this telling me to shade? Everything in between -infinity and 4. So that goes this way. You can't put a dot at -infinity. Please, no dots at infinity. Infinities mean arrows. They go on forever and ever. Okay? All right, it's pretty easy. So then the next section has us do the same thing backwards. So instead of graphing this, now we're gonna write it like this. So can you do that? What would this look like? Did you have your hand up a minute ago? Did you have a question?
Yeah,
about C, did you want us to write it as the inequality and the number line, or did it the one, -1, 3?
No, you can just graph it. It means the open interval between -1 and 3, but you don't have to write that out. The picture tells it. Yeah. Okay, these are your notes, right? So you wanna make sure that you ask questions, but you can do whatever you want in your notes. All right, so what about this? 4 to 6, what's that gonna look like? In terms of this right here, not a picture. We just practice pictures. I'm confident you can do your picture. But what's it gonna look like in terms of X's?
4 is less than X, and X is greater than 6.
X is less than 6.
Oh, less than,
Yeah.
sorry.
All the symbols are gonna be less than,
No.
because you're putting them in order. So 4 is gonna be less than 6, or 4 is gonna be less than X, which is gonna be less than 6. They're gonna go in order. Perfect, beautiful. All right, try B on your own. Then you figure out B. You gotta have an X in your answer, and you gotta have a 6 in your answer. What's that going to look like? Think about what it looks like in terms of the picture. What inequality is that gonna be? Let's see, let's randomly pick a number. Who's Keith Long?
Me.
Who's your dad?
Huh?
Who's your dad?
My dad, Keith.
Did he go to school here?
No.
Kevin. It's Kevin. Kevin right there. Okay. All right, well, you're Keith Long.
Yeah.
Tell me what you think about this as an inequality.
I did 6, and then is greater than, equal to.
Like this?
No, the other way.
Okay.
Less than.
That would be less than or equal to, yeah. Okay. And then an X?
Yeah, I did the less than the infinity sign.
You don't need to do that. Don't put infinities. Don't put infinities in an inequality.
So is that how you would leave it?
Okay, me personally, no, because I've got this, he's right. This answer is absolutely correct. I've got this hang up, I guess you would call it. I like to have my variables first. So instead of writing it this way, I would write it this way. But don't these two things say the same thing?
Yeah.
Both of them are 100% perfect. In an inequality, only put the numbers. Don't put any infinities in it. Think about it. Have you ever seen anything? You've never seen anything that looks like that, right? No, we don't do that. Just put the numbers in. If an infinity is involved, it means your picture is going to have an arrow. Right? So yeah, both of those are fine. Either one, whatever, works best for you. All right, how about C? Can you write C as an inequality? So you're writing it like this. What would that look like? Who's Stella? All right, Stella, what do you think?
-1 is less than X less than 5.
Take a look at that.
Less than or equal.
What?
Less than or equal to.
Oh, we need an or equal to, Stella, on that 5, because why?
It's shaded.
It's shaded, yeah. You're not related to Barrett, are you, by any chance?
Maybe.
Oh, man.
I'm different though, not him.
I love him. I love him.
Okay, good.
I love him. So I'm not sure you love me, but I love him.
No.
So you understand why we gotta put an or equal to on that?
Yeah.
Okay, perfect. Okay, number 4. Now we're going to go backwards. We're gonna finish these 3 and then we're going to lunch, okay? We'll finish these 3 problems. Here we go. Write in interval notation. So I want you all to take a minute. Write them in interval notation. Now that means with the parentheses and the brackets. That's what interval notation means. parentheses and brackets. And if you feel like you got it, I want you to bring it up and write your answer. Just do one, let others have a chance. But write your answer, your interval for problem A, B, and C. You're using parentheses and brackets. Kaylee, here, who's Kaylee Gibbs? Okay. Josh is here. Owen. Did you?
Yeah.
Owen, Hayes, okay. Aaron's here. Joe. Is it Joseph or Joe?
Joseph.
Joseph?
Is it Lashana?
Yep, you're Joseph. Keith? Izzy's here. Addison Miles. Addison? Addie? Megan? Eva? Tyron?
Right here.
Did I say that right?
Yes.
Is that what you go by?
Yes.
Tyron? Lucas? How do I say this word? It's Rodriguez and Gulo. How do I say your first name? Ulessi? I apologize in advance for what I do to that. Titus is here. Jose? Aiden? Jack? Amaya?
I'm here.
Did I say it right?
Yeah, you did.
And Diego. Okay, quickly, let's check, whoa, nobody did this one. Nobody did this one, not good,
That's cool, yeah.
not good, what's that look like?
4 and 9.
We have a 4 and a 9, that's probably the easiest one, right, in parentheses. And why are they parentheses? Because no or equal to's. All right, how does this look, everybody? Let's grade it, what do you think? You think it's right? Should we have a bracket and a parentheses like that?
Yes.
Yep, our numbers are in the right order, perfect. Ooh, what about this one, writing it as an interval? What do you think about that one?
That is correct.
That is correct. Who did that? Who did it? Perfect. Interesting, you put a parentheses here on the end. Why is that? Infinities are always parentheses because you can't ever put a closed dot there, right? Don't they just keep going and going and going? There's no spot to put a dot. So that's beautifully done. Good job. Okay, here's the scoop, folks. We are back in our seats at 12:45. In your seat, 12:45. No messing around. In your seat, 12:45. I had you in summer school, didn't I? Did you take Grace's name? Who's your sister? Oh, yeah. You look like her, though. You look like her.
You're not gonna wait for me?